Alright, welcome back everybody. Let's start on day 2 of the Pihut Maker Advent Calendar, 12 Projects of Codemas. Alright, let's go ahead and open it up. So day 2. See what we've got. So it looks like we have a red, amber, and a green LED, some resistors, and some jumper wires. Alright, Maker Advent Calendar day number 2. Let's get blinky. Welcome to day 2 of your 12 Projects of Codemas Advent Calendar. Today we'll be playing with one of the most popular components for makers, LEDs. LEDs are a staple component for makers of all experience levels, handy for indication, feedback, or just for a bit of blinky. LEDs come in all sorts of shapes, sizes, and ratings, and are everywhere in our daily lives. In your PC, your home, your car dashboard, vending machines, spaceships, and more. Box number 2 contents. In this box you will find one 5mm red LED, amber LED, and a green LED, 3 330 ohm resistors, 4 male-to-male jumper wires. Let's go ahead and open this up. Alright. Today's projects. Today we'll be programming LEDs to light up, flash, and display sequences, building on yesterday's code using GPIO pins to control them. We'll also be learning some new functions in MicroPython to introduce some new elements to your code. The box includes 3 different colors to allow us to have some fun making light patterns. What is an LED? An LED is a light-emitting diode. These components emit light when electrical current flows through them. Our LEDs have 2 legs, one longer than the other, as they have a specific polarity, which means that electrical current can only flow in one direction, and if not, the LEDs can be damaged. The long leg is the anode, and the short leg is the cathode. Current must always flow from the anode to the cathode, so be sure to read our wiring instructions below carefully to make sure that you get this bit right. Resistors. LEDs usually require a current limiting resistor when using them with a microcontroller. Resistors limit the amount of current that can pass through a circuit, which helps avoid the LED trying to pull more current than our Pico's GPIO pins can safely provide, and equally protects the LED from too much current. It doesn't matter which side of the LED the resistor sits, as long as it's there, they're limiting the flow of current for the entire circuit. Take a look at the comment section for an example. Raspberry Pi Pico pin map. Here's a simplified map of the pins on the Pico, known as a pinout, to help you with the next steps in the rest of the calendar. The numbers in the gray squares are the physical pin numbers, which are numbered in order around the board. The GPIO pin numbers, which we use in our code, are in green. You can also download the full PDF version here. Alright. Construct the circuit. First, make sure your Pico is disconnected from the USB cable. You should always do this when amending a circuit. Then grab the set of jumper wires, resistors, and LEDs. Alright, so we're not plugged in. We're going to be adding components to our breadboard. Breadboards allow you to connect and prototype a circuit without soldering, using wires with pins at the end called jumper wires, sometimes called DuPont wires. These breadboards have two sets of horizontal channels, red or blue on both sides. These breadboards have two sets of horizontal channels, red or blue on both sides. All the red pins are connected, as are the blue, but each side is disconnected from the other. We use these to create rails of connections for us to use, such as ground for the blue channel and the 3.3 volt for the red. The holes in the middle are connected in vertical lanes, with each lane having 5 connected pins either side of the divider. The divider stops both sides connecting together. The circuit. Place the 3 LEDs in the lower section of the breadboard, one hole apart, with the longest leg to the right as seen in the image below. You won't know which color is which yet, as these LEDs have clear lenses, but that doesn't matter, and we'll come back to that in a moment. Your breadboard should look like this. Alright, so the long leg to the right. Alright, there's those. The shortest leg is the cathode and the long leg is the anode. Alright, we now need to add a resistor to limit the current that the LEDs can draw from our GPIO pins. Place a resistor between the left leg of each LED and the lower blue channel like below. We'll be connecting that blue channel to the ground pin shortly. Alright, so let's see. So that looks good. You can see. I'm not sure how clear the video is, trying to zoom this in. Now grab the jumper wires. You need one wire connecting to the blue channel to a ground pin on your Pico. We suggest using physical pin 38 like we've done in the diagram below. You also need to connect the right leg of each LED leg to a GPIO pin. Use GPIO 18 physical pin 24 for red, GPIO 19 physical pin 25 for amber, and GPIO 20 physical pin 26 for green like the diagram below. It doesn't matter what color jumper wires you use. Okay. In an ideal world, we would reserve black for ground, red for voltage, but for simple projects it's not essential. Alright. Hopefully you can see that. Activity 1. Everything is hooked up. Let's code some Blinky. Alright. Activity 1. Light each LED. A simple exercise first. Using some of the code we learned yesterday, we're going to light each LED, wait 5 seconds, then turn them off. To do this, we need to introduce a new module to you, time. Note, assuming you turned off your computer after yesterday's box, you may need to jump back into Thonny and run the configure interpreter again. Okay. Alright. And there we go. So it looks like we have red, green, amber. So we need to switch 2 of them. Alright, let's try this again. Let's stop it, start again, and there we go. Turn this light off actually. Alright, activity 2, flashing LEDs. Let's make things a little more interesting by making our LEDs flash. To do this, we need to introduce while loops into our code. Technically, you could just repeat the on-off code above, but that would make your code very long indeed and would eventually end. So let's look at a better way, but perhaps not the best way. We'll show you another way in the future, in a future box, once we've got the hang of MicroPython. We also need to introduce variables, indentation, and code commentary. While loops are used to repeat a block of code as long as the condition remains true. Imagine you're bouncing a ball while your friend counts how many bounces you've completed. Your condition might be bounce the ball until you count 5 bounces. After 5 bounces, you would stop. We can tell a while loop to run a block of code until a count or certain condition is met, or we can just make it repeat forever by using while true, which is useful for projects intended to keep running. So we're now going to make our LEDs flash 10 times, then stop, and we'll show you how to in just a moment. Code commentary. We're also going to start adding commentary in our code examples. You could add comments in MicroPython by adding a hashtag before the comment. This will be ignored by MicroPython. Adding commentary makes explaining your code easier to others, or even as a reminder to yourself when you return to a project a number of weeks or months later. It's a very good habit to get in and allows us to explain each line clearly. Variables. A variable is just somewhere to store a value, a container, which we can also update when we want to. When we need to use the variable in a line of code, we just use its name. In our example below, our variable is called counter. We create this before the while loop and set an initial value of 1. In programming, a variable can be a whole number, an integer, a number with a decimal place, a floating point value or float, or a word/text, a string. Indentation. Our while loop says if the counter is less than 11, run the code indented below. Indentation is a gap at the front of a line of code, usually a tab space or a number of spaces. It's very important in MicroPython as it tells Thani that the lines belong to a particular block of code. In our example below, we've indented the lines under the while loop as the code belongs to that loop. The code. The code below first imports the things we need as always, sets our pin numbers as we've done them before, then creates a variable called counter, which we'll use to count how many times we've run the block of code. We start a while loop using while counter is less than 11, which is saying while the counter variable is less than 11, ... Our code prints the counter to help us see the value changing in Thani, then simply turns all the LEDs off, then on again, with half-second pauses in between. Without the pauses, it would be so fast we wouldn't see the flashes. At the end of the block, we add +1 to our counter, then it starts the loop again. As soon as that counter variable reaches 11, the loop stops running and the program ends. Copy this code over to Thani and run it the usual way using the green button. So let's copy this over and run. All right, and we see the counter reach 10 and then stopped. Try changing both of the time.sleep values to different numbers and see what happens. It should change the speed of the flashing LEDs. You can also change the while loop to run forever. Swap the line out with the line below to give that a try. The counter will continue to increase in print, but won't change the color, change what the code does. All right, so let's just do time.sleep is 0.1. Oh. All right. Activity 3, LED sequence. We're now going to make our LEDs flash one after the other in a sequence. Yes, like a festive decoration. While there are more advanced ways of achieving this, using lists, for example, which we'll cover in a future box, we're going to keep things simple while we continue to learn MicroPython. The program for this is very similar, however, we changed the LED control section to turn each LED on one by one, turning the others off as we go. Try the code below, paying attention to the off-on comments next to each LED control line. Alright, so let's hit play. Alright, day number 2 complete. Another great day of learning how to code with the Raspberry Pi Pico and MicroPython. Today you have created your first circuit, learned how to use the time module to add delays to programs, learned how to use while loops and conditions, learned about variables, our counter, learned about code commentary, and we created a dashing flashing sequence of LEDs. Please do not disassemble the circuit, as we're going to be using it again with the contents in the next box. See you all tomorrow. Alright, hope you guys enjoyed that. Thanks for stopping by, and see you again tomorrow.